All right, today we're going to do permutations and combinations. So on this first one, we want to list the number of possible letters of two letters from A, B, and C if the order matters. So the order matters. So if I start off and I say one of them is AB, what is another possible combination? Throw it out there. Come on. BA. Okay, so we can do that. What else can you have? Come on. You got it. What is it? CA. What else? CB. What else? BC. And what else? AC. All right, so how many possible combinations did I just come up with? There are six possible combinations. So when the order matters, this is what we call a permutation. In the next one, it says, okay, so how many combinations of two letters if the order does not matter? All right, so let's start it off. What's one of my, what combination can I put here? So we're starting over. So we had AB on the first one. Over here, when the order mattered, I could put BA. But over here, it says the order does not matter. So can I put BA here on this one? No, I cannot put BA over here because if the order does not matter, AB and BA are the same thing. So what else can I use that doesn't involve AB together? Yep. CA. And is there one more? CB. So on this one, when the order does not matter, there are only three possible combinations. And this is what we call a combination. All right, so let's say that you guys still used your lockers. And when you do your combination, if the combo was like 1, 10, 15, does the order matter in which you put in your locker combination? Okay, so when the order matters, your locker is actually a permutation. So your locker combo, that's what that says, is actually a permutation. When does the order not matter? So combination would be like a committee. So it doesn't matter if they were like voting for 3 positions. It doesn't matter if you get picked first, second, or third. If you're on the committee, you're on the committee. It's also like if you had a pizza and they were throwing some toppings on it. Like, it doesn't really matter if they put the pepperoni down first or they put the anchovies down first, it's just going to show up on there. So we have permutations where order matters and combinations where order does not matter. So we can teach you a lot of things of how to put it in your calculator. So in your calculator, we have NPR. And so the N is going to be the total number of items to choose from. And the R is going to be the number that you select. So if you go back to the pizza one, so maybe they have 20 different items for you to choose from, but you're like, I'm obviously not putting olives and anchovies on it because that's nasty, and so I'm only going to pick 2. I'm only going to pick sausage and pepperoni. So that's what that looks like. For those of you that don't have a calculator handy, then you could put it into Desmos, and it's been a minute, so I put in 12 select 3. So in permutations, I'm writing it again, order matters. All right, so if I wanted to put in 12 select 3, so if you had this calculator, first thing you're going to do is you would put in your 12, the total number of items, and then you have this PRB, probability button right here. And so when you open it, there are 3 different choices. We have permutations, combinations, and this exclamation is factorial. So here I would hit enter. In the next section, I would arrow over to select the combination. So you just arrow over to select what you want. Oh, apparently there's more. Okay. And then if I wanted to select 3, then I would put my 3 in and hit enter. And so you would get 1,320 possibles. We did a problem like this the other day. I'm changing it a little, and it says, how many ways can 5 teams in the National Central League finish in the standings? And so this team is going to come in first, and then how many teams are left to come in second? How many are left to come in third, and then fourth, and then fifth? So the other day when we were out in the hallway and we were doing a similar problem, it said, how many ways can 5 students sit in 5 different seats? This is the same thing. So there are 5 teams that could come in first, and then after that there are 4 teams that could come in second, 3 that could come in third, 2 that could come in fourth, and 1 that could come in fifth. So sometimes in a problem like this, it's easiest to do the fundamental counting problem. That's what I'm doing right here, where you just multiply them together. So when you multiply 5 times 4 times 3 times 2 times 1, what do you get? 120. So there are 100 different ways they could finish. All right, so if you wanted to, so this one, the order matters. We have 5 teams here, and so the N is 5 in this case. That's your total. The R is also 5 because I am going to select all 5. So in your calculator, you would go 5, hit the probability button. Make sure you select the P for permutation, and then hit the 5, and then hit equal or enter. And your calculator should also say 120. So if we're only selecting 5 teams, then it's probably not that big of a deal. Maybe if you were selecting, if you wanted to place all 10 teams in a league, you're like, how many different ways can 10 teams finish? Well, that's when I would definitely do this, because I don't really want to go in my calculator. 10 times 9 times 8 times 7, da, da, da. So, number 2 says, how many ways can the top 3 horses finish in a field of 13? So we want to know the top 3 horses right there. So that means R equals 3. So that's how many we're going to select. In a field of 13, that one is your total. So visually, here's what's happening. So I want my horses, I want to know how they can come in first, second, and third place. So I have a field of 13, so I have 13 horses that could come in first place. After that, there are 12 horses that could come in second. And then there are 11 horses that could come in third. So in these, sometimes when the order matters, using the fundamental counting principle and just kind of making these hash marks and just multiplying it, sometimes this is the easier way to do it. So what do you get when you multiply these 3 numbers? Okay. So there's 1,716 different ways they can finish. Let's make sure our calculator agrees. So order matters, so this is a permutation of 13, pick 3. So the biggest number, the total possible always comes first, and then the equal or little number comes second. So if you did it in the reverse order, if you went 3, P13, I think it says like domain error, it gives you some kind of an error. It'll tell you if you screw up. So if you hit that and put that in your calculator, you should also get 1716, and we should match there. I'm going to hit the pause button. Y'all are going to do 3 and 4. All right, so on number 3, I have, I'm going to select 5 cards out of a deck of 52. So if making the hash marks makes better sense in your head, so I'm going to select 5 cards, so that's why I made 5 hash marks. There are 52 cards to choose from when I select my first one, and then I'm not going to put it back, so I have 51, and then 50, and then 49, and 48 cards to choose from. So when you multiply that out, there are 311,875,200 possible ways this could happen. And if you just did it in your calculator, you would go 52 P5, and you would still get that same answer. How many ways can 10 people line up in a row for theater tickets? So my total is 10, and my R is also 10. So if you drew out hash marks, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, you would have 10 and then 9 and then 8, 7, 6, 5, 4, 3, 2, 1. You multiply all that together. Or this is the permutation of 10 select 10. And either way, you should get, that is a million, 3,628,800 possible ways that 10 people can line up. All right, so all those were permutations. This backside is going to be combinations. And so in the combinations, the order does not matter now. We don't care. So some of the things that a combination is pizza being selected for a committee. If you have a choice of like reading books, like you're in an AP course and they say, okay, so over the summer you have 10 different books to choose from and I need you to read 3 of them. So nobody cares which book you read first, second, or third. You just gotta read the book. So here, the N is still your total. The R is still going to be the number that you select. That doesn't change. And so when you enter it in your calculator, so your first number is going to be the total. You're going to hit probability, and you're going to have to arrow over and choose the C for combination. And then you can either just put in the number you're going to select, or you could hit enter and then put in the number. So on these, when the order does not matter, you can't do the little hashtags like we did before. You have to do the formula in your calculator. So I'm going to make a pizza, and I have 15 toppings. That should say toppings, not topics. And you are going to select 3. So the N is 15. Those are how many options you have. Your R is 3, because that is how many you are going to select. How many different pizzas can you make? So this is a combination problem. So you're going to go 15C3 in your calculator. And you should get 455 different possible pizzas that you can make. So all these numbers should be smaller than what we had on the previous side. Basically, why? Because, I mean, if you want a sausage, a pepperoni, and a ham pizza, that this is the same thing as a sausage ham pepperoni. It's the same thing as a pepperoni sausage ham. So when the order doesn't matter, these numbers, they kind of cancel out and they are drastically smaller. I have a reading list that has 20 books on it. How many ways can you choose for books? So this is saying nobody cares. The order does not matter. It doesn't matter which one of these 4 books you choose. You just got to read 4 of them. So that would be your N. That would be your R. So you're going to go 20C4 in your calculator. Should get 4845. I'm going to hit the pause button. You guys are going to try 7, 8, and 9, and I'll come back to you and show you the answer. And here we go. So on number 7, we're going to elect 4 candidates to a planning board. Okay, so they just chose to call it a planning board. And so when they phrased it like that, that said the order does not matter. However, if it had said that we're going to call one of you president, vice president, etc., this would be a permutation problem because the order matters. So if they give people a title, then it's a permutation. Here, it just seemed like the board was like a committee and the order didn't matter at all. So that's why I chose the combination option and not the permutation option. A lottery has 49 numbers, and why should I not play the lottery? Hundreds, thousands, millions. Because there are 13,983,816 different ways that you could draw a ball from the hopper. The chances of winning are very slim. This one may have been quite surprising. So I have 39 people, and I'm going to choose a jury of 12. And so there are 3,910,797,436 possible ways in which we can select the jury. So we have a lot of different options there. Here we're just going to read it and try to decide, is this a permutation or a combination? So you have to remember that in permutation, the order matters, and in combination, it does not matter. I'm going to test 3 of the top 10 ranked laundry detergents. How many ways can we select them? So when you read this, does this say to you that the order matters or the order does not matter?
It doesn't matter.
Order does not matter. I believe that we have talked about this one even in our Algebra 2 PLC when we were doing this one. We decided that the order does not matter, but if you could give a reason, because sometimes I think the first time around I read it ranked, but it doesn't matter. So I'm just going to test 3 out of the top 10. So I would concur that the order does not matter. So therefore you would do a combination. Very good. Yeah. I never look at you like you're stupid. I look at you like, make sure you think through it all and don't always go with your first instinct. Yeah. An employer must choose 4 equally qualified applicants from a pool of 15. How many ways can the 4 applicants be chosen? Order doesn't matter here? Nope. It doesn't matter. So they were all equally qualified. So we said that this was a combination because your order does not matter here. On the last one, you're going to choose a president, a secretary, and a treasurer from a committee of 17 people. How many ways can this be done? Well, okay, so you're selecting from a committee but I'm going to give them a title, and I'm going to call one of them president, one of them secretary, one of them treasurer. So if you were on a committee, and do you think that a president does something the same or different than a treasurer? They do something different. So since these play different roles, then I said, therefore, the order matters because they have different, very specific jobs. And so, therefore, this was a permutation. All right. Go do your homework.